we are doing probability again. Yeah. So we need to remember what we talked about last week. And I know it's been a long time, so I'm going to remind you. So here, let's look at the questions, and then we can look at the answers. How many outcomes are there from tossing two number cubes? Remember, that's two dice, right? Labeled 1 through 6. So here's 1 all the way to 6, right? 1 all the way to 6. And then what's the sample space for 4 equal sections of a spinner? How likely is it that a probability of 1 will happen, and how likely is it that a probability of 0 will happen? So we want to answer those questions looking at our book, the very first page, 490, page 490. Look right here. So the number cube has 6 sides. If there are 6 sides on one dice and 6 sides on another one, then 6 times 6 is 36 different ways it could land. 36, you say. And I say, yeah, I don't believe it. No, it's true. Because look, over here they show you. They say you could have a red, if you had two different colors, you could tell the difference. If the red one was 1 and the blue one was 1, or if the red one was 2 and the blue one was 3, or if the red one was 3 and the blue one was 5, or if the red one was 6 and the blue one was 2, right? There's 36 different ways. How do I know that? Because there's 6 ways that this can land, and then the other one, whatever color the other one is, there's 6 ways this can land. 6 times 6, 36 different ways they can land. That is the ticket. So, how many possible outcomes are there? There's 36. Right? So the answer, she is 36. Okay, what's the sample space for a spinner that has 4 colors? Well, looky here. The spinner is right there. There's 4 different colors. So when we say sample space, we're just saying what could possibly happen. Well, when I spin it, it could land on red or blue or green or yellow. So that's the sample space. And so that's the answer to this one. That was a 6. Doesn't look like a 6, does it? And so what is the sample space? This is the sample space. Whoops. Everything from here to here. That's the sample space. How likely is it that an outcome with a probability of 1 will occur? So here we go. See, if it's 0, it's impossible to happen. It'll never happen. If it's 1 or 100%, it's always going to happen. It's an absolute certainty. And then the closer you are to 100%, the more likely something's going to happen. And the closer you are to 0, the less likely something's going to happen. So if we had a really tiny fraction, like 1/12, that wouldn't happen very often. But if we had a really big fraction, like 7/8, well, that's going to happen. And same thing with percent. If it was 3% or 11%, we'd say, well, that's not very likely. But if we had 88% or 93%, then we'd say, oh, baby, that's pretty certain. That's going to happen pretty close to all the time, right? So we know the answer to this. How long, where's my sample space? There we go. How likely is it that if the probability is 1, it's very likely, right? It's certain that it'll happen, right? It's always going to happen if the probability is 1. And if the probability is 0, it's never going to happen. Never, 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 never. So we know that. So now let's look at a couple of these. So, whoops. We probably should clean out the crud so we don't have to look at these scribbles. Well, it would help if I had a An unscribbler. There we go. 1, 2, 3. Get that out of there. Get that out of there. Okay, here we go. How about this one? A farmer has 4 sheepdogs and 3 beagles. That'd be fun. Have 7 dogs. Can you imagine feeding them all? How much dog food they'd eat? And then how much poop? That'd be a lot. But he's a farmer, so it's out in the dirt and the grass, everything. That's okay. All right, so here we go. 4 sheepdogs and 3 beagles. If he randomly chooses a dog, what's the probability of him taking a walk with the sheepdog? And remember, you always have a fraction with what you want to have happen on top. And then on the bottom, it's the total things that could happen. So, in this one, there are 7 dogs that want to go for a walk. And the probability that he chooses a sheepdog, there's 4 of them. So 4 chances out of 7 is the reason, is the answer. What's the probability of him taking a walk with a sheepdog? Now remember, probability can be written as a fraction, 4 divided by 7. You always start by making it a fraction. But you can also write percent if you want. So that would be 50, whoa, you can't see that. That would be 57.1%. Or just if you round it off to 2 decimal places, it'd be 57%. But you can say 57.1% if you want. So where can we write that? We can write that right here. 57.1%. Of the time, you'll discover that they almost always want 3 decimals. So that's why I do that. The 3 decimals were 571. So whenever I make it into a percent, it's 57.1. Yeah, that's almost always what they want. Okay, so look, Gordon spins a spinner. So a spinner, it has 6 equally sized things. Quadrants, they're not quadrants anymore if there's a spinner. Sextants, I guess there's 6 of them, right? So if they're all equally sized, then the likelihood that it lands on a 1 would be 1 chance out of 6. And the likelihood it lands on a 5 would be 5 chances out of 6. And anytime you have or in the sentence, that means add them together, right? Whoops. Did I do that right? No, I did not do that right, because what did I say? There's 1 chance, 5, silly me. There's 1 chance that it would land on 5. There's 1 chance that it would land on a 5. And there's 1 chance that it would land on a 1. So 1 plus 1 would be 2/6. Now then remember 2/6 you have to reduce. That would be 1/3. So 1/3 of the time you would expect it to land on a 1 or a 5. So you're adding 1/6 plus 1/6. That makes 2/6. And remember that's 33 1/3%. So depending on how they ask, sometimes they'll ask for percent, sometimes they'll ask for fractions. You have to be able to do both, right? So if you want a percent, you just divide the fraction and then move the decimal. Oak trees shade the Fitzgeralds' backyard, 30% of the backyard. So what's the probability that somebody standing in the backyard will not be in the shade? Here's the kicker, right? So if 30% of the yard is shaded, then when you want to find not, remember that's called a complement. In math, that's a complement. So 100 minus 30, that would be 70% chance 70% chance that they're standing in the sun, right? 30% is in the shade. That means 70% is in the sun. Those two numbers are complements of each other. Find a probability that the point chosen inside the big square is also going to fall inside the small square. Where is that? Oh, the square's over here. I have to slide. Okay, so the question wants to know what's the probability that if I'm throwing darts, if I'm throwing darts at this dartboard, it's a square dartboard, I want to know what's the probability that it lands in the center, right? So I have to do the area that I want, which is the small area. So I'm going to write A small. And then the area that I want is A big. Right? So all I'm doing is taking the area of the big square. Remember, it's a square. So if it's a square, that means this side is 6 and that side is 6. So the big one is 36. And this side is 2. If it's a little square, and that side is 2, then the little one is 4. So what's the probability that if I'm throwing darts at this dartboard, how many times is it going to land in here? What's the probability that it lands in there? Well, it's 4 out of 36. 4, whoa, come back here. 4 divided by 36. Now you can't leave it like that. You got to reduce. If you're going to leave it a fraction, you have to make it into a lowest terms fraction. So this one is 1/9 of the time. 1/9 of the time, if you divide 1 divided by 9, that turns out to be 11.1% of the time. Yeah, how about that? How about that? Let's look at another one. Let's look at another one. So I need to erase all my crud here, so we can get rid of this, and that, and that, and that, and that, and that, and that, and that. And then, oh, it's working better than the last time I used it. Must have been plugged in all night long, so now we don't. The batteries are working just right. Come on, baby. Yeah, well, there goes. There we go. One more. Boom. 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 All right. Let's look at this. There we go. So here's the deal. We pull a marble from a bag and then write down what color it is and then put it back in the bag. Stir it up, do it again. And so they did this over and over and over. Now you have to know the total. They didn't give you the total. So one thing you have to know is how many times did they do this experiment. So we have to add 30 plus 17 plus 53. So you have to add them together. That's 100. Oh, well, that was nice. So the total times that they did this experiment was 100. Total. Right? There we go. Total times. So what's the probability that I get a yellow? Well, it's what you want to have happen. Remember, what you want to have happen is on top. And then the total things that could happen is on the bottom. Total, that's an O. There's the A, total things. So 53 out of 100. Right? So if I pick a yellow marble, that's going to happen 53 times out of 100, which is 53%. If you know what percent means, it means out of 100. So 53% of the time, you're going to get yourself a yellow marble. Now, not choosing a red. This is the complement again. Not choosing a red. So if there's 100 total, you have to subtract 17, right? And so 100 minus 17 is 83. And so not choosing a red would be 83. Here, where can I write that? 83 out of 100. So when I reach my hand in the bag, 83 times out of 100, I'm not going to have a red. That's what I'm saying. Because I'll have a yellow or a green, right? That's what happens. If you don't get a red, you have to come back with a yellow or a green. So the complement is that this does not happen, right? Now choose a red or a green. Remember, or means add them together. So I know the probability of red is 17. And the probability of green is 30. So 17 plus 30, I'm just adding these together, all divided by the total number of things that can happen, which is 100. So 17 plus 30, that's 47, huh? 47 out of 100. So 47 out of 100 is the chances that you would get a red or a green. Now, think about this. What's the complement of that? Well, that would be not getting a red or a green, which means you get a yellow, and see 53% is the complement of 47%. So we did it right. Yay. We did it right. There we go. And then which color of marble is greatest in number? Well, I would expect there to be more yellows than there are reds and greens put together, right? Because of the way that it looks like. Right? There are more yellows. Yes? Sounds good to me. Sounds good. Let's look at one more thing, and let's see if we can figure this out. Oh, gotta clean it up. Gotta clean all my junk out. Oh, there we go. Oh, that's working good. One more. There we go. Alrighty, so here we go. So as part of a grant to improve the bus routes to and from school, Hogan and Jane, two people, gathered traffic flow statistics for an intersection. They make a table showing their findings that happened in the 15 minutes right before school started, right? On Monday morning. So, we're going to look at these statistics over here, and we're going to find the probability that a vehicle turned north. Now, look at the way they write it. So, mathematicians are lazy. They don't want to write too much. So, we're saying probability that it turns north. Look what they did. PN. P stands for probability, N stands for north. What's the probability that it turns north? Now we know what we want goes on top, everything goes on the bottom, so let's look over here. What's the probability that it actually turned north? So before we can do anything, we have to add all these numbers together. 282 plus 94 plus 188. That's the first step. I have to add those together. What is that? You add it, I'll add it. Let's see, that plus that looks like a 4. And then carry. So that plus that plus that, is that 6? Then carry, is that 5? Did they count 564 cars? I think they did. That's how many they counted. So if I'm turning north, that would be 94 out of 564. 564. So here, a decimal or a fraction would really help. So 94 divided by 564 turns out to be 16.7%. You see that? So well, you can write the probability as a decimal, 0.167. You can write it as a fraction. You can write it as a percent, 16.7%. So 16% of the traffic turns north, right? Now this next one says turns north or goes straight, right? Turns north. Now remember, or just means add. So we know that turning north is 94 out of 564. And then going straight is 282. 282 out of 564. So when we add those two together, we'll get the probability that it goes north or it goes straight. So when I add those together, I get 376. 376 out of 564. And once again, if we divide by 564, we'll get, we'll get the little, what did I do? 564, we'll get the percent, or the decimal, 0.667, which we know is 66.7%. So they either go north or straight, 66.7%. Right? Well, if you're changing it into a percent, don't forget the percent sign. If you're going to leave it a fraction, you have to reduce, which that would be 2/3. Right? So 66.7, this round reduces to be 2/3. So 2/3 of the time, they go straight or they go north. Of course, that means 1/3 of the time they go south, right? How do I know that? Because that's the complement, right? You're either going south or you're not going south. These guys aren't going south, so the complement of this would be 33. So I know that this happens 33% of the time. How about that? So see, we can do it. We can do it. And we're done. You should be able to do today's homework without any trouble. Bye.